Hey guys, how's it going? Derek Craig here with another Oilfield Basics Discover Podcast episode. This is episode number 63, and today we're going to be talking about somewhat of an introduction to data science, specifically on with production operations. So, a very deep topic here that we're just going to be starting to skim the surface of. Definitely a hot topic, and I'm probably in the same boat as many of you guys listening, trying to figure out what exactly is data science and kind of where are the boundaries and like what all does this include and how do we even go about this? And so we've got a gentleman that's going to help shed some light on all of these questions and more. Before we dive into this though, just a couple quick announcements on our end with Oilfield Basics. Hope everybody's doing well. I know last week's episode was a little bit more grim because it was recorded on the day that oil went negative. So I guess that's a plus. So we're back in positive territory. So there we go. We got that going for us. So we're on somewhat of an upward trend if you look at it from that regard. But either way, I hope everybody's still doing well and keeping their head high. And I also want to thank everybody who's been reaching out to me personally and through the company, through Oilfield Basics, about either courses or in support of what we're doing or whatever be the case. I've had a lot of people reaching out to me lately and kind of answering the call, right, that I've been making to help with creating material and stuff during this downtime. Everybody's a lot of people have extra time on their hands and really hoping to put people's time to good use to really create resources for others to be able to learn from and really help make our industry better for when we come out of this downturn or even through it, that people can keep learning with this extra time on their hands. So thank you everybody who's been reaching out to us on that end. And also, if you follow us on LinkedIn, you might have heard a little bit of a buzz that we are going to be doing some form of an internship program. So that was kind of a spontaneous decision, but at the same time has a lot of very good perks, and we're building the program right now and trying to figure out all the specific details and how we want to handle all this. And we'll begin accepting applications very shortly, and actually probably by the time this is released, it will be this week in a sense. So we'll probably start taking applications for that. So again, we're just trying to help provide some of these students that had fantastic internships perhaps even lined up and was looking for a really good educational summer, really trying to help provide them a resource to keep on learning and also use them to help us create content and enable others in our industry to create content also. So just wanted to throw that out there. Like I said, you guys might have seen that on our LinkedIn, on our channels and stuff. So keep an eye out for that. More announcements and more details on that to come. And I'll also throw in too, as we actually start the internship program this summer, you might even hear some interns on this podcast. So that'll be pretty exciting. So just a little heads up on that end. And as always, I'll encourage anybody listening to please rate the show and share it with a friend. That helps others to find us and also keeps our rating strong. So I appreciate that in advance. So like last episode, in case you didn't hear it, episode number 63, we talked with a gentleman named Philip Das. He's with Simon Kucher and Partners, and we discussed a survey that they sent out to different industry leaders and managers across oil and gas industry, not just E&Ps, but also oilfield service companies and also international companies. So we've got a pretty good range of people that they interviewed for that. And so that was a pretty good episode. Go back and listen to that if you want to really get a sneak peek on what the leaders think, how long it's going to take for us to come out of this and what issues they're currently facing, and CapEx cuts, all the scoop on all that stuff. But one of the things he mentioned was talking about the fact that companies that survive through all this are going to have to evolve some way, shape, or form. And there's lots of different options for that. But obviously one of the big distinctions and things that can help is data science and using this kind of stuff to our advantage. And like I said, we're going to get a deep dive into this part of the industry and hopefully understand it a little bit better here at the end of this episode. So with me today, I've got Kenneth Nguyen. He is co-founder of Tasq, and he joins me. How are you doing today, Kenneth?
Great. Thanks for having me.
Absolutely. I'm excited to dive into this topic because, like I discussed with you previously, I'm just one of those people that know the buzzwords, and that's about it. So don't really understand how to use it or do it, or what background you have to have or what all it includes. So really hoping you can help clear up some of this for us today.
Yeah, hopefully I can at least shed some light by scratching the surface.
Yeah, I'm sure this is a pretty big category in a sense, and this is something that I hope to work with other individuals and companies across our industry to really get some good material on, because I really do think this is going to continue to obviously be a big part of our industry, and I really have a lot of solutions embedded in all this. But tell us a little bit about yourself, your past experience, and how you got into this.
Yeah, so as I mentioned, I'm co-founder at Tasq. What we do there is you can think of it as smart task management for the oil field. We take in essentially high frequency data, push it through a bunch of machine learning algorithms, and come up with essentially a smart task list. So, what the failures are, what you should be attacking from a day-to-day basis. Before all this, so I started in the industry about 10 years ago at Shell as a completions engineer for the Haynesville asset. So back when natural gas was really booming, I think at that time there was maybe 9 rigs in Haynesville that was drilling. So it was pretty busy, and we were a pretty small completions team. So started out there, kind of learning the ropes in the completions operations side of things and engineering. Did a field assignment there as well. So about 1 year doing a field supervisor role. So that was also pretty eye-opening as well. When you go to the field from the office, it's a little different. Always a humbling experience.
Yeah, a little bit of a different culture, right?
Yeah, definitely. But learned a lot there. I think one of the main benefits you get from being on the ground is you just have a better, I guess, intuition about how things are running, what's feasible, what's not feasible. So that was good. Then Henry Hub crashed a couple years after I started, and it got shuffled into the Gulf of Mexico asset doing P&A work. So did that for a short stint. That was a good learning experience, but I don't know if I would want to go back there.
I'm sure that's very different from anything onshore that you were doing previously.
Yeah, very different. Going from producing wells to essentially capping wells.
Right. Yeah.
Yeah. And then after that stint, still at Shell, I got onto a team that did a bunch of completion effectiveness designs, I would say, or initiatives. So part of my role was doing competitive intelligence of just kind of the onshore completion space. So I think at that point, the shale boom was just starting, and really it was just a matter of trying to figure out the completion design space, how much proppant to push or to pump down, stage spacing, frac interference, so well spacing. So there was a lot of, I would say, kind of trial and error, gathering data. That's kind of where I started getting into the data science, or really statistical learning.
That was going to be my guess. That's all so heavy with data. Those things you were mentioning.
Yeah, so that was pretty interesting to work on that team, and then that was about 5 years into Shell, and then I came over to BPX, which at the time was just BP, I think just the onshore division. Now it's BPX. So I came on as an optimization engineer, which I guess you could say is sort of the optimization engineering role. My responsibilities were mainly helping build, maintain production optimization systems, and using data really to solve systemic problems. So that's kind of where I really started getting deeper into the data science field. So really, how I got into it was I had no background in it at all, coming straight out of school as an engineer, and really I got into really coding because as a completions engineer, you're just pushing out procedures, and a lot of them are cut and dry. So I built essentially this like a Excel VBA thing to automate the whole process, because I got really annoyed with spending hours just trying to gather data, put things together. So and that kind of led into the statistical learning stuff.
Okay.
So.
Yeah, so I just see how this has just been progressing, through all these roles. See a little bit more of an application in every single one. So that's pretty cool. And then on the production optimization side, I mean, what was a lot of the stuff that you were dealing with there? Was it mostly like artificial lift? Was it like kind of day-to-day operational organizations, or like maintenance stuff?
It was I was mainly focused in operations, so really embedded with with the operations team. So a lot of that was really, kind of understanding the problem. I would say, 80 to 90% of data science really is about understanding the problem. And so, getting out into the field, kind of seeing what the field techs were seeing, what problems they were running into. A lot of the issues we were tackling, was, how much deferment do we have today, right? What's the production for today? What are the repeated failures? And really setting up systems to start measuring that and be able to essentially quantify, deferments caused because of this much or these failure types, right? And so kind of putting a value to the problems that you want to prioritize and attack first. So that was some of it. Specifically there's pretty niche problems, I would say, like artificial lift problems. For example, for plungers, trying to figure out, how can you at scale detect when a plunger is about to fail or you're about to get a missed arrival, right? So kind of niche problems depending on the field that you're in, but really problems that you would see and encounter pretty much every day.
Gotcha.
Yeah.
Well, definitely a very cool background. I can see how it kind of led into all this and with what you do with what you guys do at Tasq and whatnot. But so let's kind of dive into just the name of data science, right? So I guess what all does that kind of what does that mean to you? Like where are the boundaries here? I don't know. Just introduce help sort all these names, these hot topics, the AI, the machine learning, data science. Where's the lines?
Yeah. So data science, it's an interesting field. It's constantly evolving, right? And I would say it's kind of a blanket name for a lot of different disciplines of what people do.
Okay.
I came into it really from kind of the technical, I guess, domain knowledge side, right? So on the petroleum engineering side, and really just learning data science to help solve my day-to-day problems. And I think, most people will probably approach it that way. I would say that if you were to really kind of break it down, and this is still a gross generalization, but you can think there's kind of the infrastructure side of data science. So I think really you're trying to churn through all this data. So there's the infrastructure side, so data engineering, backend. Engineering, that sort of stuff, that really just to set up the databases, set up that pipeline to get data flowing, right? Then there's the data analysis, data visualization side of things, which is kind of really how I got into it. So data analysis, you can think statistical learning, so really just basic statistics on the problem that you're trying to solve, or exploratory data analysis, which is really just, you're using data visualization, certain statistical tests to really tell you a little bit more about the nature of the data, right? So is it biased? Is it kind of skewed to one side? Does it have a wide distribution, narrow? So these are all things that kind of tell you characteristics about the data, right? And data visualization, you can get, that's a whole field in itself as well.
Okay.
But it's great, a great tool as well. We're visual by nature. We're visual learners, and we spot things better visually, right? And so it's a great tool in conjunction with data analysis to kind of gain your insights. And then there's kind of the core, I would say, core data science, which are definitely people who have a lot more training and education than I do, writing the data science, machine learning algorithms, AI algorithms. But part of it, I'm kind of lumping in there as part of that is using those tools and knowing how to use those tools. So, so there's many different skills in data science. I would say, one of the or probably two of the most generalized thing in common across all of them is technically, you should know how to code. you don't have to be a great coder to learn data science, but just a lot of the tools, statistical tools or data science tools are in some sort of coding language, whether that's R or Python. It's good to know those tools, right?
Okay.
And then the other one is communication and storytelling. Really, what you're trying to do is, as a data scientist, you're not just kind of in the books and the laptops, figuring out or writing these algorithms. But once you get your results, be able to communicate them to either decision makers or tell a story that kind of spreads that insight.
Okay. Yeah, and so I guess that's probably a big part of all this too, is not only getting all the front end work, but also if your end result isn't something that people can utilize, right? There's kind of no point in doing all of that, right?
Yeah, and I would also say that you don't have to be an expert at all of these, right? I think people tend to gravitate towards certain areas of data science. So, for example, for me, I gravitate a lot more towards the data analysis, the kind of data engineering side of things. But pretty familiar with using the other tools, machine learning tools, and other statistical tools as well.
Okay, so on some of these things for like statistics, data engineering, data visual, like some of these can they stand alone by themselves, but then also like are in somewhat of an order if you're actually trying to create a full model. Do you know what I mean? Like,
yeah, no,
okay.
I think at some point in your data science career, you're gonna essentially touch all of these, right?
Okay.
I would say you may start in one, right? So let's say statistics or data analysis. Pretty easy to get into, just you can just grab a data set online and start kind of doing some statistical learning or machine learning just around that, right?
Okay.
But then maybe, let's say now you have a model that you built, a statistical model that you want to deploy up to be used, right, frequently. So then you're kind of getting into, okay, so where do I host it? Where does the data start coming into to feed the model? These kind of start, creeping into these other disciplines, I would say.
Okay, gotcha. Gotcha. And so your experience was pretty much on the data, which part again?
The data analysis side.
Okay.
Yeah.
Gotcha. So but I
then,
guess. Oh, go ahead.
Yeah. I was gonna say, but then kind of as I needed to solve other problems, that kind of led to, all right. Gotcha. So how do I then incorporate these other?
Gotcha. Yeah, it's a little bit of a rabbit trail, right? You can't just do one of them, right? You get. I guess if you tried a little bit of coding or whatever and maybe didn't like it, then maybe you'd stop. But for the most part, I assume you'd probably keep going with it.
Yeah.
Probably get a little bit addicted.
Yeah. I mean, I would say, once you get the coding bug, sometimes you can't stop. Right. But there, I think there are other aspects of data science that, you don't necessarily need to be great at coding, right? Like there's definitely project management roles where you're kind of overseeing this problem that I would say you're trying to oversee this problem that you're trying to solve that involves data science as well, right? And so I would say there's definitely kind of there can be a project management side of things because a lot of times the problems that you're trying to solve are multifaceted and multidisciplined, right?
Mm-hmm. Gotcha. So what point do you start trying to do data science in your own life? Predict things around the house, appliance failures, money spending habits.
Yeah, I mean, actually, those are good projects, actually. So, definitely personal finance is a great way to start. I mean,
see if you can trip up your own model. Throw out a curveball. Here, take this.
Yeah, just set up a anomaly detection model and see, if you spend something outrageous and it text your phone a bunch of times.
Yeah, it's text it. You should return it now.
Yeah.
Yeah, you're not home yet. Go back.
Right.
Yeah. Yeah, so I guess, obviously Yeah, and you've seen this in your own career. Definitely like to hit on it more here on this episode. Is what applications you see for data science and specifically production operations. I know we could talk about this with applications all over the industry. It really sounds like your background, being production, also what you guys are doing with Tasq and stuff. So I guess let's kind of start hitting on that. I guess where do you start seeing the opportunities there?
Yeah, I mean, I would say there's lots of opportunities, particularly in oil and gas,
Mm-hmm.
and specifically even in production operations space, right? So I would say generally, for most operators, they're data rich, in a sense. So,
Yeah.
most wells are going to be capturing, you know, tubing, casing, pressures, flow rates, right?
Mm-hmm.
Maybe you'll have some sort of reporting system that captures certain failures,
Mm-hmm.
downhole, maybe surface. But
Production
there's generally,
metrics and yeah.
yeah, there's generally a lot of data available, right?
Mm-hmm.
But I would say most operators are pretty early in terms of the data insights maturity,
Mm-hmm.
right? So kind of understanding or utilizing that data, maybe it's high frequency data, time series data, or just failure reporting data, or
Mm-hmm.
even cost data, right? So um, utilizing that to kind of its full potential. I'd say most companies are pretty early on in that stage.
Mm-hmm. Or even and
So
even too,
you,
like every people who have that data and stuff, I'm sure like different business units might keep it in different places. I mean, what's the how feasible is it to really make one solution, apply it for the whole company? And it's like nobody really started collecting data, I suppose, with this in mind. I mean, if you go back to I guess whenever we first started, getting what like Signet, like those types of applications and stuff that
yeah,
really capture all the information from the field. So really
yeah,
crazy.
definitely. I mean, I think most of us are going to be approaching this in this industry as we have this data now. What can we extract from it, right?
Mm-hmm.
Which is, a fine place to start. I think certainly with the current state of the industry data, there's
Mm-hmm.
quite a bit of value that you can
Probably better to
extract.
do sooner than later. Also.
Yeah. The ideal approach would be, kind of figure out what problem you're going to solve, and what sort of data that you want to capture or measure,
Mm-hmm.
right? But, of course, we don't live in an ideal world, but you just have to deal or roll with what you've got.
Yeah, and probably often have to like go back and recondition data and everything. And
Yeah. A big part of data science is really about cleaning the data, understanding the data, figuring out which data is important, which isn't.
mm-hmm.
Really, the easy part is actually the data science part, right? So the tools that you're applying to it. It's all that upfront work of preparing your data set, and pushing it through. So
Yeah, yeah, and even understanding, I suppose, probably too, like what data you can and can't trust, and the relationships within those data is right. Like, does this drop in pressure actually equal this, other metric, or does it correlate or not? So.
yeah, which is great. It's a good segue into being embedded and knowing the day-to-day operations, right?
Yeah,
So,
yeah, that's it on that.
um, I would say typically, your production operations day probably looks like spending a lot of time, waking up in the morning.
Step one.
Production's down. Why is production down? Lots of people, engineers, team leads trying to put together data to figure out, all right, these are the wells we need to hit, right?
Yeah.
And then finally, when you got your hot list of wells to go to, you dispatch field techs to go on their route and
Mm-hmm.
maybe try to fix a well. But maybe that fix is something that they've done repeatedly that just has a short-term effect, right? So it's kind of
Mm-hmm.
this Groundhog's Day of figuring out what's going on and applying kind of a band-aid fix only to fix it again, right? The
Right.
next day.
Yeah.
Um,
Job security.
yeah, yeah, definitely. Drop all those soap sticks
Right.
whenever you can.
Drop another one. Might as well.
Yeah. But the thing is like, ultimately these are just a culmination of a lot of little problems that you're essentially just solving every day, right? And it's the same small problems that you're trying to solve every day. So it just turns out that these small problems make pretty good data science projects. So because of that, right? Let's just say that you have a small problem such as you're restarting an RTU out in the field every 3 days,
which is
whatever,
basically
right?
just the brains, right, on site that collects all the data and sends it, right? Just for anybody who's not familiar with RTU.
Yeah.
Okay.
So so the automation equipment, a lot of times it's maybe you're changing out the batteries a lot, right? So then it kind of gets down to the question of, well, why are you changing out the batteries? What type of batteries are you changing out? Which ones are better for the system over the other? I mean, these are problems that, or that particular problem can be answered by, if you measure out, have one data set of these type of batteries, another data set with these other types of batteries, or different size voltage batteries or whatnot. You can use statistics to kind of tell you, yeah, this is statistically significant. You should go with battery B then rather than battery A, right?
Okay.
Another good problem is even just trying to solve the problem of what's your deferment for today, right? I think most companies are probably using some sort of decline curve to figure out what their day-to-day production loss is, but decline curves are really geared towards long-term forecasts, right? The day over day is pretty noisy, and therefore your deferment numbers could be pretty noisy.
So
and
deferring,
really
you're just meaning like lost production, right, or downtime.
Yeah.
Okay.
Yep. And so, trying to figure out that deferment number, you probably want to use some sort of shorter term metric to capture in, what's the normal noise profile of this particular well for production, and therefore you can account for it in your deferment calculation, right? That's a pretty good project. Even just clustering wells geographically, based on where they are spatially. There are machine learning methods to essentially cluster those wells together spatially, so that you're not trying to do it by hand or kind of eyeballing it. But again, this is where I think the devils are in the details, right? So understanding the problem, right? So that's kind of a surface level understanding of the problem, right? So let's take the routes example, right? So you're trying to cluster wells together to form routes. Well, if you did it from kind of a high level, you may approach it as, all right, we'll just take the lat longs and we'll apply this clustering method to cluster these wells together, right? Really, it's a little bit, the problem's a little bit deeper, right? So if you were to go out to the field and kind of ride around with a field technician, then you may understand, well, we can't really cluster these wells together because there's literally a river that splits this area, right? And if you were to cluster them together, then you might have to drive an hour around the river, right? Or to find the next bridge, or maybe there's a fence in the way. So I think that's kind of where in data science, right, I think that's one of the things that makes a good data scientist is understanding the details to that level, right? Kind of getting out there and getting your hands a little dirty away from the office, and really understanding kind of the true nature of the problem.
Yeah, and I guess also too, like whenever you're talking about like failure detection, right, or like prediction, I get whenever you there could be so many different causes of it, and let's say like some of the items in your data set in a sense would include something that would basically be an anomaly. So like something happened on surface, or some type of damage that is unnatural or not very typical, right? So like, how do you just have to go through like manually, you like filter all this stuff out whenever you're building models, or like how do you deal with, I guess, noise, from the
system? So it's a good question. So I would say that most people think that data science is, you know, uh, you come in, you have this algorithm, push data through, and you get some awesome result, right? The reality of data science is, when you boil it down to it, it's really figuring out which column or which field in your data set is, gives you a better model, give you a better result.
Mm-hmm.
And in order to do that, you kind of have to understand, where is that data coming from, right? So let's say you have a field for, I don't know, let's say line pressure, right? Is that significant or not? There's a bunch of tests that you can run, but it's also good to understand, where that data comes from, right?
Mm-hmm.
So maybe it's actually being reported from a third party who does a certain thing with their meter that gives a certain result, right? And it's good to know that because that means that you need to discount it, or maybe you need to do something else with that data.
Mm-hmm.
So I would say a lot of it, a lot of understanding what data to use and what not to use is one, knowing where the data comes from, and two, I would say where you have outliers, don't exclude them. I would say
Try to figure out
understand,
understand them.
understand where they come from, right? So
Mm-hmm.
maybe you have this outlier that happens, every month or every few months, and that could actually just be, someone out in the field doing a particular action,
Mm-hmm.
right? Um,
Mm-hmm.
but those outliers can be say fed into a machine learning model that maybe that's actually a leading indicator, right,
Mm-hmm.
to a failure.
Mm-hmm.
So I would say it's a good chunk of it is really just understanding where the data comes from and really understanding the problem.
Mm-hmm. Now, is there going to be like some, I guess, operators or situations that might not be in as good of a position to utilize data science? So, like, does it come down to? I mean, obviously, people who don't have data being pulled from their operations. So, someone who just has a well and all manual gauges, right? They're not going to probably be able to get much help out of data science. But does like field latency and like the frequency of pulling the data and stuff, like, does that all really make or break whether or not someone can utilize data science to build models on stuff? You know what I mean? Like, who all can kind
Yeah,
of partake in this party? You know what I mean?
yeah, no, definitely. Definitely if you're reading manual gauges and you're getting production off of your circular chart, then that may be a little bit limiting
Yeah.
um, in terms of what you can do with data science. You could probably still do it, if you manually log those numbers
Give
day
them
over
an app.
day. Yeah, in an app. You could probably you build a robust data set over time. Might take a while,
You'd
but
probably have a lot of anomalies there too. A lot of fat finger fudging, right, and everything.
yeah,
Numbers, and
might have to account for it.
someone
Maybe
drives off. What was that number
person
again?
yeah,
Just makes
might
a
have to account
guess.
for some personnel bias, right?
Right.
So, um,
Right.
but in general, if you have a SCADA system, even if you're collecting data um, once an hour, maybe it's a day late. I would say that you can still extract some value. Now, granted, there's probably certain problems that you just need a better data fidelity to get into. So, I would say certain time series failure prediction problems.
Hmm.
You might need a little bit granular data, but yeah, I would say in general, you can still, with hourly data, you can probably still get some sort of at least trending anomalies
Hmm.
that you can extract insights out of. Um, but I would say that yeah, it just depends on the problem that you're trying to solve, and you'll know, I think, as you dig into the problem, you'll understand, maybe the model that you were building, the statistical model or the machine learning model, you've done all you can, and the results are still poor. It may be an indication that you need additional data, whether that's in the form of higher frequency data or other contextual data. So data that essentially is coming from either another measurement or another system, whether that's reporting or whatnot.
Yeah. So for example, like even what tying into like, so if you're doing optimization on production related systems, like even tying into ongoing completion operations, right? If there's like a nearby frac or something that could be interfering and affecting some of this, or like that kind of extra data.
Yeah, that kind of extra data. Generally, I think as you the one thing that probably should be cleared up is, data science and the projects that you embark generally isn't a finite start and end project. It's generally I would call it a journey. It's a journey of you get data, you build a model that helps you gain insight on the problem, you understand the problem better, and then that informs you of what other data to collect. And then you kind of start that process over again. It's a kind of a meandering path to getting to full understanding of the problem and the ideal solution.
Right. It's kind of like having a kid, right? You're kind of stuck with it for 18 years, got to train it up and adjust it. He might bring along his friends every now and then, right? Or something like that.
Yeah.
Yeah. So one thing I want to hit on, and I know one of the things we wanted to discuss was kind of the process of actually executing on this. But one thing I just want to hit on before we get there is like, the business case for this kind of stuff. So I'm obviously going to take, resources and time, and we'll kind of get through that in the process that you're going to outline for us. But in terms of like business use cases and stuff, like how do you know if it's going to be worth it to go down the path, and I guess, what all can you try and optimize? I mean, I know we've kind of talked about, failure analysis and things relating to artificial lift, but, I guess what else can it expand to? I know it's probably a never ending list, but just a couple more ideas here from you.
I think ultimately, it kind of boils down to, time and money, right? So if you can, if there's a problem that you kind of know costs a lot of money, maybe you're replacing a lot of batteries for your RTU or whatnot, right? That's something that you can probably quantify, right? This is you're spending this much yearly on batteries, right? This is the size of the prize of in terms of cost, right? You're not going to completely get rid of batteries, but there's some percentage or some savings of that, right? That you can kind of estimate, what you might save, or even just time. So maybe there's a process for, an engineering workflow process that you want to optimize or really just save time around, right? Engineering hours are expensive. So if it's something even as small as, there's one project I heard of, these psychometric charts, right? You have, 5 axes, and, for an engineer to kind of look up, maybe the dew point of something given the ambient temperature and the pressure, that might take, maybe 30 minutes to kind of line all those things up. To automate a process like that, and maybe that engineer does it every day, that's a pretty good value case.
So they're not always like ginormous projects or anything. So
I would say, no, they don't always have to be ginormous projects.
There's a lot of little wins you can have along the way.
I think
projects.
Yeah, it starts out with the low-hanging fruit, right? Anything that can help you, really anything that can help you make decisions faster or save on cost, or even, the holy grail of saving cost and improving production, right? I think there are a lot of low-hanging fruits just flying around. And I think one thing to notice that, or to be able to notice that, is really to see it from kind of the field perspective, right? I think as a data scientist in the industry, it's very easy to try to look at the problem from kind of top down, right? I would say a lot of data scientists in oil and gas, maybe they're located in the office, right? Maybe they don't go out to the field very often, or don't have the opportunity to go out to the field very often. I would say that when you're at that perspective, a lot of times you're the hammer looking for a nail, looking for a problem to
Mm.
solve. If you're coming at it from the other way around, when you're in the field, there's problems all around, right?
Mm-hmm.
You know, if you do a ride along out in the field, I would say that you notice kind of the problems that the field technicians are handling on the day-to-day basis.
Mm-hmm.
And I think that is a good start for kind of framing up and understanding what problems are you really tackling out
Mm-hmm.
in your day to day. So
Gotcha. No, good insight. I appreciate that. I know you, and you come from a background that you've done all this, so I appreciate that. So I guess general process here. I guess we can just start diving into this. And so one of the questions in my mind too is, I guess, kind of what buy-in or how much guidance do you need even from management to begin? So like, do you need management to even have like a pretty broad vision for the entire company on this is how data is going to be structured? This is how what I mean? Like, the
yeah.
to what extent do you need that? Because I was kind of having a general conversation with someone about AI before, and like that makes a big difference if you have someone from the very top just preaching it all the time, and like everybody's on the same page, and it's not just these one-off projects that engineers are doing and may or may not get used, maybe just by them for a year, or like, what's your take
Yeah,
on that?
from my experience, I would say it's a little bit of both, right? You, it's kind of nice to have, from one end of the spectrum, these one-off projects can lead to kind of something bigger, right?
Mm-hmm.
And being able to have that freedom of let's just try this, see what happens, see what the results are.
Mm-hmm.
Maybe it's something valuable and might surprise us. Um, on the flip side, right? If that's the whole thesis of your data science program, then it's going to be pretty chaotic, right? People are going to be using data sets that they keep on their personal computer, and
Right. Yeah.
that's not shared across, and
File permissions gets messy.
yeah, and you might have two or three people working on the same problem uh, at once, and they don't even know it.
Right.
So I think it is important to have a plan in place that also allows for kind of that sandboxing kind of moments, right?
Okay.
But in general, I think with data science, it tends to be good to kind of have a plan or a roadmap of at least kind of the vision of where you anticipate or hope that data science will land you, right? So, kind of being able to have this vision of, you know, uh, not having to go to the well site
Mm-hmm.
for, months at a time, right? Because you're able to kind of prevent these problems. Um, Having that vision and then working backwards from that, you start to understand the hurdles or the milestones that you really need to achieve in order to get to that vision.
Okay.
So it's really, kind of working backwards from there. At the same time, kind of solving problems on the front end. It's nice to have that vision and work on that vision. At the same time, the boat has a million holes that you're trying to plug up and keep
Right.
afloat, right?
Yeah.
So there's definitely just very near-term problems that in the industry, there's something called, tech debt, right? Sometimes you just have to, which means that you kind of have this short-term solution that is going to be scrapped for kind of a longer-term solution that you're
Mm.
going to build, but you just need something to band-aid
In the
right now.
meantime,
And
yeah.
yeah, and sometimes that's, part of the reality is that, yeah, sometimes you just need to uh, band-aid something now. There's value in the short term of fixing that problem,
Mm-hmm.
knowing full well that maybe that solution might be scrapped, but you're going to build essentially a longer term solution. So,
Gotcha.
so long story short, but basically, it's important to have that vision and
Mm-hmm.
have the teams around to kind of solve those short-term problems and work on the long-term solution to get you that vision.
Gotcha. No, I appreciate that in your perspective. So process, where do we start?
Whew, process. I think one of the important things about data science, I think that we probably overlook a lot is design, right? So if you
Mm,
remember, if you went to an engineering school, there's the whole design process of building a product, right? If I kind of barely remember that, but it
right.
comes back to um, to bite me every now and then. But really, design is pretty important. And when I say that, really, the first step is, how are you framing that problem, right? That you're trying to solve. So, um, you know, what's the right question to ask? What's your metric of success? How do you know you've succeeded? You know, essentially, is it solving the problem that this person is seeing? Is it
Mm,
delivering the insights that you're expecting? So really, it starts with understand the problem. So um, that includes, going out there to the field,
hmm
understanding, the nuances of that problem. So that's probably the first step. And then, understanding the value impact of that problem. So, there's going to be, a million problems that are happening on the day to day, and it's really understanding that value impact and how that prioritizes essentially, and um, whether it's in your team or you're an organization. So, um,
hmm
you know, there's a million things that we should be doing, but there's only a few things that we can really get to, right? And then, I'd say once you've identified that it's a high value problem, and you kind of understand some of the nuances. Part of that is part of the next step is really to build a team around that, right? So I would say there's only so much that you can do yourself. Even as a data scientist, you know, I may not know where to get the data source, right? So buddying up with someone in maybe the IT side, or someone
hmm
who knows or has access to that data is important. And even just working with a field technician, or working with someone who's really knowledgeable in that
On the
problem
specific
domain, or
problem. Hmm
yeah, is really important. I would say that's apart from kind of identifying the value and knowing that it's an important problem to solve,
hmm
getting the right people in the room is just as important. Um, and that is everything from solving the problem to even deploying the solution, right? Because as a data scientist, you may not be the one that deploys it at scale, right?
hmm
That could be, maybe someone in an IT department, or whatnot, but or even just a someone in leadership, right? That can help push that solution.
hmm
So there's kind of this whole team organizational
hmm
problem around it, but yeah, I would
Yeah,
say that's
one
that's
question
pretty
I'll
important.
throw out for you on the team though too, and maybe you're biased on this one, maybe you're not on this question, but what do you think would work better or be a better way to success team wise? Whether it's someone who's like an engineering background with like a production engineer or whatever who knows how
Mm,
to code, or whether it's you know a specific data science team that's not like not a production, like they're not coming from the side of the problem, they're coming from the side of the data and how to handle it in the solution, and then trying to
right.
understand the problem. Like, does one kind of work better than the other? Because I know like different companies have different approaches to that.
Yeah. I would say that if the benefit of like a centralized kind of data science team
Mm-hmm.
is that once you have a working solution, it's easy to scale, right? That team generally can implement it in other parts of the organization. The hard part, or the difficult, or the challenge for that centralized team is really uh, understanding the details of the problem, right?
Mm-hmm.
So they're um, one of the missteps the team could have is they implement a solution that really doesn't solve the problem. Maybe it solves part of the problem, or maybe not enough of it, right?
Mm-hmm.
Then there's the flip side of having the engineer know how to code and do data science, which is where I kind of came from.
Mm-hmm.
You understand the problem to a much more intimate level, right? And so you can kind of design this solution that works very well. But then now you might have this problem of how do I bring it from one asset or one area of the company to a different area?
Mm-hmm.
And you kind of need a little bit of both. And I'd say the important part is that interaction, right? Between, engineer who developed this very specific solution and the centralized data science team, or maybe IT team, I would say working together to help scale that problem up in the organization. Um, it's it, it's not a clear and cut, this or
Right.
that. It's
I didn't
always
figure it
kind
necessarily would be, but I knew
yeah,
you'd have
it's
some insight.
the answer is always going to be a little bit of both.
Right. Always a little
But
gray.
yeah, always a little gray.
Yeah.
I think, one industry that does this quite well, I think, is, of course, the tech industry, right? So there's a good article out there on, or actually, I think there's a good YouTube video on how Spotify essentially structures
Mm.
their team, or their teams,
Okay.
and it's pretty interesting. It's a good watch, but they essentially take these kind of focus teams that focus on particular problems, and they pull people from different disciplines in, right? That essentially forms this working team. Yet these people kind of have these dotted lines that they report to that essentially is their discipline kind of structure, right? So there's kind of the discipline. Maybe you're a backend engineer, right? Working on this thing at Spotify. There's a whole kind of organizational tree there, but yet you work on this team day to day, solving this other particular problem, right?
Mm.
I don't know if that makes sense. It's
Yeah, no,
Spotify.
for
Spotify
sure.
definitely explains it a little bit better than I did, but there's this kind of notion of through these sprint teams that you are on to solve a particular problem,
Uh-huh.
yet your proficiency, your discipline, may be managed by kind of that other discipline tree, right?
Mm. And we're in perfect times to have collaboration opportunities.
Yeah, yeah,
And,
definitely.
everything's seamless right now. Easy to work with people halfway across the world.
Yeah. Um,
anyways, anyways, not to derail you from your step
oh
by
yeah,
step
no,
here, but
no
so build a
worries.
team,
Yeah.
and then what we got after that?
Yeah, so after you build the team, really it's about gathering the data, right? So I think this is kind of an iterative loop at this point, or the start of the iteration loop. But you gather data, you kind of research, where that data comes from, and maybe build your initial solution. It
Hmm.
might work great the first time. It's likely not going to work great the first time. And you find out you need more data, you need more
Yeah.
feedback. So a lot of the times, the important thing to realize is that you're building these solutions generally for someone else, right, to use. So maybe you're building a tool. Part of it has a data science aspect to it, this algorithm that might provide an insight, but that's targeted generally to an end user, right? So maybe that's a field technician, an optimizer, maybe another production engineer, but they may be using
Hmm.
this tool to then solve their problem. And so um, part of the iteration loop is getting this user feedback, that then becomes additional data to either build a better model or revise the tool. And it's this kind of iteration, continuous improvement loop, to then, hopefully you won't ever build the perfect tool, but you'll at least build a tool that's better than the last one.
Gotcha.
Yeah. And
Yes.
then in certain circumstances, you may just be doing maybe a static analysis, right? In which you arrive at a decision A or B. So, for example, in that battery example, maybe that could very well just be a finite start and end project, and you arrive at some decision. But I would say most generally, you're probably working on a problem that is always continuously evolving as you find out more, um, have more insights.
Gotcha. Yes. Anything else on process wise, or is that? And I know you had some tips you wanted to share with anybody who's looking to get into this. And
Yeah, I think off the top of my head, I covered most of it. I probably missed a few steps or nuances there, but hopefully that wasn't too long drawn out.
no, pretty good
Uh,
timing. It's actually pretty good time. We're getting right at the end, so you
cool,
timed it
cool.
well. But yeah, no,
Yeah,
definitely a lot of good insight that I think you were able to add to this and at least get the ball rolling. We're kind of just give a little bit of a direction. Obviously to anybody who's trying to figure this out for themselves, or an engineer like me who's just getting started. That is
yeah,
this something I want to start learning more about? Just having that fundamental kind of background and
yeah.
first step into this. And
And so far, kind of what we've talked about, I'd say it's you're kind of getting little bit, I'd say, deeper into the data science profession, right? And one thing I want to add to that is, you know, you, as you're building this solution that someone might be using, right? One of the
mhm,
important things is, how do you build trust in said system or solution?
mhm,
I think a lot of times, it, a lot of times with data science, you might implement a solution in which the end user may have no idea what's going on, right? It
yeah,
spits out an answer and it just doesn't make sense, right?
right.
And at that point, you've deteriorated all trust in that the system is working, right? And
Right.
so, yeah, I think it's one of the important things is part of this user feedback is also to uh, be able to explain what maybe your algorithm is doing or what your model is doing or what the tool is doing, and where it messes up, then trying to be transparent around where is it messing up. It's messing up on these types of problems.
Hmm.
So really providing to that end user this kind of transparency around
Hmm.
what's actually happening. um, but that's sorry, a little bit of a digress
No,
from
it's perfectly fine.
um, from what you were asking, but to back to tips on getting started. It doesn't have to be something huge, right? Or a sophisticated data science algorithm. You could start pretty simple, and I would say one of the first things, at least what's worked for me, is starting on a problem that is nearest and dearest to you, um, i.e., what's the one thing in your day that annoys you the most,
Right.
and solve that problem, or maybe find a streamlined solution for that. Generally, that if it's annoying me enough, then I will want to try to solve that and make
Yeah,
it less
it's a good
annoying,
place to
right?
start. Yeah.
Yeah.
So there's your number
um,
one tip to get started. See what annoys you most.
yeah. See what annoys you most in the day in terms of your day to day,
Yeah.
and see if there's any data that exists on said problem. Um, generally there probably is data that exists that someone has access to, and that may take, depending on the size of the organization, may take a
Hmm.
little bit of kind of researching and figuring out who knows who that might have access to that data. Um, Otherwise, if there's no data around it, then it might be good to start collecting
Hmm.
that data. So just to either build up a value case, or to uh, you know to to build up a value case for measuring that data more continuously, or maybe building a team around that. So,
Gotcha.
And then the other thing that I would also start while you're doing all this is start learning Python or R. I would say those are the two most common languages in terms of data science. I lean towards Python a little bit more just because it integrates well with other systems. But R is actually super powerful. These are all free, by the way, so people can get these off the internet. R being just the letter R, but that's also a very powerful statistical learning tool. It's actually designed for statistical learning tools. So anyone who's familiar with MATLAB will probably be pretty familiar with R, but that's a good start. And then learning materials, there's this one particular one, if you're just getting started, called Introduction to Statistical Learning with applications in R, but there's also I believe someone's online that kind of converted that to Python as well. I can send you the link to this material, but yeah, it's that particular book is free. It's by a bunch of people out of Stanford that made this publicly available. So it's a great learning material, great resource just to get into really the fundamentals of statistics and some entry into machine learning. So
send it to me and I'll throw it in the show notes for people to click on.
Yeah, definitely. Other than that, what I did a lot was a lot of YouTube tutorials, Googling. It helps actually. This all goes back to the problem that you're trying to solve for your project, right? Because it kind of anchors what you want to learn to solve next in your many steps of problems to solve. And then the other thing I would say is finding a mentor or kind of community group. So this may be something that already exists in your organization. Maybe there's lunch and learns around learning data science or around statistical learning. If there's not, then there's actually tons of meetups. I would say in most cities, meetup.com is a great place to start to really just find people in your area to start learning data science and getting involved in that community.
Gotcha. Yeah, no, definitely appreciate the tips, and thank you for taking the time out of your day to come on the podcast and share this with the rest of us. And like I said, send me that link. I'll drop it in the show notes for anybody to use as a good reference for getting started. And then I'll also throw out the pitch again. If obviously I'd love to have more material on this on Oilfield Basics, also as a resource for people to go to and get started. I know I've talked to some people that are kind of interested in maybe helping out with that. So if you yourself or Kenneth or anybody listening is interested, please let me know. Definitely try to facilitate and put that out there as a resource for people to use, and hopefully even also get you some revenue off of it as well. So just my little sales pitch for the day. But thanks again, Kenneth, for being on. And I'll also throw a link to Kenneth's LinkedIn profile in case anybody wants to reach out and have any further discussions with him. So thanks again for being on today.
Cool. Thanks for having me.
Awesome. Well, thanks guys again for listening. Like I said, be sure to drop a rating on the show and share with a friend, guys. Thanks and take care. And we'll catch you in the next episode. Stay healthy.